Good morning, students. Good morning, math enthusiasts. In our previous discussion, we solved for simple applications of solutions to right triangles. This time, we shall discuss some complicated word problems involving angles of elevation and depression. Let us review a little. The angle of elevation is the angle formed by the horizontal line of the observer's eye level and the line of sight from his eye towards his observed object, when the object is above him. This picture below from www.mathbitsnotebook.com gave an illustration of the definition of an angle of elevation. The angle of depression is the angle formed by the horizontal line of the observer's eye level and the line of sight from his eye towards his observed object when the object is below him. This picture from mathbitsnotebook.com provides a concrete example of the angle of depression. Example number 1 was taken from www.mathbitsnotebook.com. The problem is, a radio station tower was built in two sections. From a point 87 feet from the base of the tower, the angle of elevation of the top of the first section is 25 degrees, and the angle of elevation of the top of the second section is 40 degrees. What is the height of the top section of the tower? Following the steps we made in our previous discussion on simple applications of solutions to right triangles, we start with an illustration of the problem while reading the problem partially. A radio station tower was built in two sections. So, we draw a vertical line divided into two parts, the first section and the second section. From a point 87 feet from the base of the tower, we now create a horizontal line connecting the base of the tower to a point on the ground that is 87 feet away from the base of the tower. In our illustration, we only make estimation of the distance at a particular point. The angle of elevation of the top of the first section is 25 degrees. We now connect a line from that particular point on the ground to the top of the first section of the tower. We label the angle formed as 25 degrees. And the angle of elevation of the top of the second section is 40 degrees. We also label the bigger angle formed as 40 degrees. Now this angle formed is drawn or found when we draw a line connecting the same particular point on the ground to the top of the second section of the tower. What is the height of the top section of the tower? The top section refers to the second section of the tower, and by the way, the illustration here was again taken from www.mathbitsnotebook.com. At first glance, it is difficult to find the height of the top section of the tower, since we do not have the height of the first section of the tower. We need to find the height of the first section of the tower before we can find the height of the top section of the tower. In the illustration, you can see two overlapping triangles. Actually, two overlapping right triangles. There is a small right triangle with angle 25 degrees, and there is also a big right triangle at the back of the small triangle with angle 40 degrees. Looking at the small triangle, we shall represent the opposite side, which is the height of the first section of the tower, as h. Observe that the parts involved in the small triangle are the opposite side and the adjacent side, so that we use the tangent function to solve for h. That is, tangent 25 degrees is equal to the opposite side h divided by the adjacent side 87. After cross multiplication, we have h equals 87 times 25 degrees. After manipulating your scientific calculator, you should obtain the height of the first section of the tower as 40.56876626 or 40.57 feet. Thus, the height of the first section of the tower is approximately 40.57 feet. Are we done with this problem? No, we have not answered the question that is asked in the problem yet. Let us now look at the big right triangle at the back of the small right triangle. The opposite side of angle 40 degrees is the union or the sum of the first section and the second section or top section of the tower. So we represent this side as h plus x. The adjacent side is still 87. We use again the tangent function. By substitution, the tangent 40 degrees is equal to the opposite side h plus x divided by the adjacent side 87. After cross multiplication, we have h plus x is equal to 87 times tangent 40 degrees. Recall that we already obtained the value of h. By substitution, the equation becomes 40.56876626 plus h equals 87 tangent 40 degrees. You might ask why I did not substitute the rounded off value. Again, I would like it to be your habit to substitute all the digits you obtained from your scientific calculator if you are going to find another unknown value to obtain a more approximated value. Now we are going back to the equation. We now transpose the known value on the left side to the right side of the equation so that we have x equals 32.43290165 after using your scientific calculator. Therefore, the height of the top section of the tower is approximately 32 feet. Now, have we obtained the required answer in the problem? Yes. Example number 2 was taken from www.shelovesmath.com. The problem goes this way. From the top of a building that is 200 feet tall, Meryl sees a car coming towards the building. Somehow, she knows that the angle of depression when she first saw the car was 20 degrees. And when she looked at it again, it was already 40 degrees. How far did the car travel? From the top of the building that is 200 feet tall, we now draw a building and label it with 200 feet. We emphasize a point on top of the building as our guide for the next move. Meryl sees a car coming towards the building. Of course, a car should be on the ground with the same horizontal line with the base of the building. So we emphasize an estimated particular point on the horizontal line formed far away from the building. Somehow, she knows that the angle of depression when she first saw the car was 20 degrees. From that particular point on the ground that we have created, connect a line to the point on top of the building that we have created. Since the problem mentioned the angle of depression, then automatically create a horizontal line on top of the building. That is the horizontal line of the eye level of Meryl. Notice that you have drawn an angle with that horizontal line on the eye level of Meryl and her line of sight with the car. Label it with 20 degrees. And when she looked at it again, at the car, it was 40 degrees already. This means that along the horizontal line on the ground, you create another point that is closer to the building. Recall that Mary saw the car coming to the building. Connect a line from that point, new point, to the point on top of the building where Meryl is located. With the horizontal line of her eye level and the line of sight of the new location of the car, an angle of depression is formed and you label it with 40 degrees. Have we created right triangles? Yes, but the illustration is quite complicated. This is an example of a complicated problem. Again, a complicated problem. We cannot directly obtain the answer of the question asked in the problem. Instead, we have to solve for a value first that is needed to find the final answer. Again, we see overlapping triangles here. Recall in a previous example of some simple applications of solutions to right triangles that the angle of depression is equal to the angle of elevation. So that we can label 20 degrees here in this angle and 40 degrees here in this bigger angle. Remember the geometry concept on alternate interior angles being congruent given two parallel lines and a transversal. The two overlapping right triangles are this one now, the small triangle and the bigger triangle. So, diri na ta mo focus. Since we are looking for the distance traveled by the car from the first site to the second site, we represent this unknown value yet as our x. We cannot directly find x, so we use another representation for the remaining part of the line segment formed, which is unfortunately not given in the problem yet. We represent this part, which is the distance from the second site to the base of the building, as y. Now our aim is to find y. Observe further that the parts involved here are again the opposite side and the adjacent side. So we use the tangent function. Now for the small right triangle, we have tangent 40 degrees is equal to the opposite side 200 divided by the adjacent side y. After cross multiplication, y is equal to 200 over tangent 40 degrees. After using your calculator, you should obtain the value of y, which is 238.3507185. Have we answered the problem already? Not yet. But this value of y will lead us to the final answer. Looking at the big right triangle, we see that tangent 20 degrees is equal to the opposite side 200 divided by the adjacent side x plus y, which is the union or the sum of the segments of x and y. After cross multiplication, we have x plus y equals 200 over tangent 20 degrees. By substitution of the value of y, we have x plus 238.3507185 equals 200 over tangent 20 degrees. By transposition, x is equal to 200 over tangent 20 degrees minus 238.3507185. Simplifying the equation using our scientific calculator, x is equal to 311.1447654. Therefore, the car traveled approximately 311 feet. Example number 3 was again taken from www.shelovesmath.com. The problem is, two girls are standing 100 feet apart. They both see a beautiful seagull in the air between them. The angles of elevation from the girls to the bird are 20 degrees and 45 degrees respectively. How high up is the seagull. Two girls are standing 200 feet apart. Write 2 points on the ground where these two girls are standing. Connect the 2 points to form a horizontal line and label it 100 feet. They both see a beautiful seagull in the air between them. So make a point above and between those two girls, which is the location of the seagull. Between does not exactly mean midpoint. It could be closer to the first girl or to the second girl. The angles of elevation from the girls to the bird are 20 and 45 degrees respectively. You may now adjust the point of location of the seagull according to the given angle measurements. The angle measurements tell us that the seagull is closer to the second girl. The angle formed by the angle of elevation by the second girl is bigger than the angle of elevation of the first girl. So far, our estimate of that point is correct. How high up is the seagull? We then create a vertical line from the point of location of the seagull to the ground. Now there are two right triangles formed. The illustration that we have created is a little bit complicated. The problem asks for the height of the location of the seagull from the ground, which we represent y in this illustration. Before we can get the value of y, we need to find the distances of the two girls from the point on the ground that is directly below the seagull, or the location of the seagull. To the left, to the right. We represent these distances by x and 100 minus x. Why 100 minus x? The total distance of the two girls is 100. If we let the first part as x, then the other part of the line segment can be obtained by subtracting x from the total distance, which is 100. Let me give you another example. Say the total distance of two persons or things or cars or houses is 7 kilometers. If that distance is interrupted by a particular point on that line, within that distance, say, a car has traveled 2 kilometers from the starting point, then the remaining distance can be obtained by subtracting 2 from 7, which is 5. To check, 2 plus 5 is equal to 7. Going back to the illustration, we have two right triangles, which involve the opposite and the adjacent sides. Looking at the first girl, we see that tangent 20 degrees is equal to the opposite side y divided by the adjacent side x. Looking at the second girl, we see that tangent 45 degrees is equal to the opposite side y divided by the adjacent side 100 minus x. The solution here is more complicated. After cross multiplication of the two equations in the previous slide, we have y equals x times tangent 20 degrees and y equals the quantity of 100 minus x times tangent 45 degrees. Since y equals y, then we can equate their equivalence. That is, x times tangent 20 degrees is equal to the quantity of 100 minus x times tangent 45 degrees. Simplifying this equation by distributive property, we have tangent 20 degrees is equal to 100 times 45 degrees minus x times 45 degrees. By transposing the quantity on the right side, containing x to the left side of the equation, we have x tangent 20 degrees plus x tangent 45 degrees equals 100 tangent 45 degrees. We usually place the quantity containing the unknown variable to the left side. Notice that in this equation, x is a common factor. Thus, we have x times the quantity of tangent 20 degrees plus tangent 45 degrees equals tangent 100 times tangent 45 degrees. Transposing the quantity with the known variables on the left side. You can see this. Okay, on the left side of the equation to the right side of the equation, we have x equals 100 tan 45 degrees all over the quantity of tangent 20 degrees plus tangent 45 degrees. After manipulating your scientific calculator with the same format, here, you can obtain the value of 733.31538291. Therefore, the Seagull is approximately 73 feet high up. As a recap, and again, in your illustration of the problem, make sure that a right triangle is formed. This right triangle becomes your basis in selecting the appropriate trigonometric function to use in order to solve for the required unknown variable in the problem. Also, there might be more complicated illustrations. Sometimes, two overlapping and non-overlapping triangles can be formed. Do not be confused easily. Stay systematic in solving problems and maintain a happy disposition while doing critical thinking. And that ends our discussion today. Thank you very much. Remember, math is easy to learn when one learns with enthusiasm. Bye!